This is the Chapter 3 quiz 1.1 and 1.2. So the first page is the graphical solves. Obviously, I can't do this to scale on here, so I'm just going to do my best. They should ideally list a scale someplace. So the scale I used, for instance, was 1 meter is equal to 2 millimeters. I like to keep the math simple because I am. So I had a line that went 415 meters, which on my scale was 830 millimeters. And then at 32 degrees above the horizon, and this is not to scale obviously, I had another line that was 300 meters. The resultant that I got was 685 meters at 14 degrees above the horizon. How close are your papers? What's our range? 700. So I would here's what I would say. I would say credit for anything from 675 to 695 is probably reasonable. That's 700. I'd have to solve it mathematically. So it's a FIP quiz. Obviously, it's all just about pride. So if they have 700 or 670, give them half. And the angle has to be within 3 degrees either way. So let's say 11 to 17. Let me guess. One more?
No, I put like 10 more.
Oh. Okay. Half off. I mean, and remember, the points are all made up anyway. This is a FIP quiz. So, yeah, they could lose a quarter point. Or maybe, no, you know what, we'll make it a point for each. So a point for the magnitude, a point for the heading. So, you know, if they're out in this range, our little outliers, they get a half off there. If they're, you know, 1 degree outside of that range, they get a half there. Say north of east or south of west, they are just wrong. That is just out. Minus this whole heading.
But they got the degree.
Don't care. Moving right along, number 2. You go 34.5 meters north. Turn and go 78.0 meters west. Resultant is, by my measurement, 85.0 meters. And we'll give a range of, let's see, that's smaller numbers. We'll give a range of 5 on either side, so 80 to 90. If they're 5 outside that range, take off half. And then for the angle, I got, let me change colors here, 76 degrees west of north. Wait a second, that's not right. Okay, so
What if you flip-flopped it, went north of west?
you can, okay, yeah, so 66 west of north, which would also be what? No, not 66. It would also be, what's the complement of
24 west, north of west.
24 north of west? Either of those is acceptable, because they're describing the same heading. They describe the same heading. Okay, so then you had some angles to identify. You have this, and you need to tell me that for 1 point that is 25 degrees south of west. Then you have this. That is 30.5 degrees above the horizon. Those are pretty easy.
You can start horizontal.
Okay, so then you have this drawing, and you need to tell me that that is 37 degrees east of south. And then you have that, which is 15 degrees west of north. And for all of them, of course, you can do, is it the complement that adds to 90? You can do the complement with the opposite thing. So we've now got the mathematical solving and resolving. You're searching for your lost cell phone in a field of tall grass, and you travel 59.2 meters north, and then you turn and head 26.4 meters west, and you don't have to draw these to scale. You don't have to be picky about angles. Now, it helps if you draw them to some level of scale, just for the visual trick in your own head, but you don't have to be real careful about them, which is lovely. So we know that our resultant vector is equal to the square root of a squared plus b squared. Resultant vector is equal to square root of 59.2 meters squared plus 26.4 meters squared. Resultant vector 64.81975,009 meters. And then our angle, we're looking for that angle for a heading. Theta is equal to the inverse tangent of the opposite over the adjacent, which is going to be inverse tangent of 26.4 meters over 59.2 meters. So theta, we have 24.03428816 degrees. And we sig fig it all, we get 64.8 meters at 24 degrees west of north for our resultant. Okay? So point for the magnitude, point for the heading, and of course within the heading a half point for the magnitude, a half point for the angle, unless they did something really bizarre like above the horizon and then it's just wrong. Alright, so we now have a 3.5 meter tall building, grass here, and we are going to put up a ladder 1.75 meters out from the building. We want to know how long a ladder we need and what angle the ladder will make with the ground when we're all done with this. So the ladder is our VR. VR equals square root of 3.5 meters squared plus 1.75 meters squared, and we get a VR of 3.91311861 meters. The angle the ladder is going to make, theta equals tan minus 1 opposite over adjacent, tan minus 1, 3.5 over 1.75, theta equals 63.43494882. So when we sig fig it all out, we need a 3.9 meter ladder, and it will make a 63 degree angle with the ground. So common mistakes to make, and this is one of the first places where you see this particular common mistake. When you're doing your trig functions, I've had students in the past who said, but I thought it was always sine, or I thought it was always cosine, or I thought, you know, look at the picture. That's one more reason that I make you draw a picture for everything. And I will literally, if you look at my keys, you will very often see the following, so that I'm reminding myself which is the opposite and which is the adjacent. Because, especially if you're a visual learner, it's an easy way to screw things up. So, okay, final answer on that. Okay, so you've climbed up to the top of the football bleachers. You traveled 6.2 meters at 42 above the horizon. What we want to know is how high up you are. That would be the delta y. So that's just your delta y in this case. This is your overall displacement. So this is a one-stepper, but you still get 2 points for it. Yoo-hoo-hoo. Sine of theta is equal to the opposite over the hypotenuse, which is equal to your delta y over your resultant vector. So the sine of 42 degrees times your resultant vector will give you delta y. Sine of 42 degrees times 6.2 meters equals delta y, so 4.148609759 meters is delta y. When we sig fig it all out, you're 4.1 meters up. 4.1 meters up off the ground. Okay, so you've got your pet parakeet escaping, flying away at 14.0 meters per second, 37 above the horizon. How fast do you have to run to stay right underneath her? Ah, come back. So what you're looking at, this is her resultant vector, her resultant velocity. What you're looking at, or for, is her velocity on the x. So we know that the cosine of theta is equal to adjacent over hypotenuse. That's your adjacent, that's your hypotenuse, and that's equal to Vx over Vr. So cosine of theta times Vr equals Vx. Cosine of 37, 14.0 meters per second, equals Vx. Okay, so we get 11.1808974 meters per second equals Vx. Sig fig it out, you have to run at 11 meters per second to stay directly underneath her. Okay. Yes, ma'am.